Today we're talking about embryology, which is, the incredible story of how every single one of us is built from the ground up. So it really all boils down to this one huge question, right? How in the world does a single cell build an entire person? I mean, it sounds completely impossible, but it turns out there's a very, very precise blueprint that makes it all happen. So here's what we're going to cover. We'll start with a 3-layered blueprint. Then we'll see how that folds into our shape. We'll meet some real master cells, check out how the heart gets built, and finally, look at what happens when that blueprint goes a little wrong. Okay, so our story really starts with the raw materials, and you might be surprised at how simple it is at the beginning. Everything, and I mean everything, comes from just 3 basic layers. I mean, look at this. It's kind of hard to believe, right? This simple little disc with its 3 layers, the ectoderm, mesoderm, and endoderm, this is the starting point for every part of you. Your brain, your bones, everything. It might not look like much now, but trust me, this is the foundation for the whole show. So what's the job for each layer? Well, think of it like this. The ectoderm on the outside, that's going to be your brain and skin. The mesoderm in the middle, that's all your heavy lifting stuff. Muscles, skeleton, you name it. And the endoderm deep inside, that forms the lining of your gut and organs, like your lungs and liver. It's amazing. Just 3 layers to build one incredibly complex person. Alright, so we've got our layers, but we're still, just a flat disc. That's not very human-like, is it? So the next massive step is folding. This is where we go from a flat sheet to something that actually starts to look like a body. And this is literally the very beginning of that process. See that line down the middle? That's the neural groove. It's where that outer layer, the ectoderm, starts to kind of buckle and sink inward. This right here is the start of our brain and spinal cord. So as that groove gets deeper, the edges, they're called the neural folds, they start to rise up. It's kind of like 2 waves getting ready to crash into each other. And their only job, their entire purpose, is to meet in the middle and fuse together. When they do, they create this hollow tube that's going to protect our brand new nervous system. And let me tell you, timing is everything. This isn't a whenever you feel like it kind of process. The tube literally zips in from the middle, heading out to both ends. And those ends have a super strict deadline. The top part has to close around day 25, and the bottom part just a few days later, around day 28. No exceptions. And that precision is why this is so critical. Because if that top end misses its deadline on day 25, that leads to a devastating condition called anencephaly. And if the bottom end fails to close on day 28, it results in spina bifida. This is a huge reason why things like folic acid and prenatal care are so important. It directly helps this incredibly precise zipping up process. Okay, so while all that zipping up is happening, something else amazing is going on. A group of cells pops up that are so important, they're practically celebrities. So let's give them a proper introduction. Meet the neural crest cells. Seriously, these cells are just wild. They literally peel off from the top of that closing neural tube and just take off. They're like the ultimate free agents. They don't stick around, they travel all over the embryo. That's why some people even call them the 4th germline. They are true master builders on the move. Just look at what they build. This is their resume. We're talking about huge parts of your nervous system, most of the bones in your skull, pigment that gives your skin its color, and a crucial piece of the heart. It's just a staggering list, all from this one little group of traveling cells. So speaking of the heart, let's dig into that. Because building a heart is one of the very first and most complicated jobs the embryo has to tackle, and it has to start working like right away. So it all starts out as a simple, straight tube. But, you can't really pump blood with a straw, right? So this tube does this amazing biological origami. It loops and folds over on itself. Then, walls start to grow on the inside to divide it into our 4 chambers. And as a final touch, the main exit pipe gets split right down the middle to create the aorta and the pulmonary artery. And you can see that whole crazy transformation right here. On the left, that's the simple starting tube. On the right, that's what you get after all that twisting and folding. This looping is the absolute key to getting all the chambers lined up correctly. It's like watching a perfectly choreographed dance. Okay, for this last part, let's tie all of this back to the real world. What happens when there's a little glitch in the blueprint? This is where the story of embryology really connects with medicine. Okay, check out these 2 conditions. So it's a normal part of development for our guts to kind of bulge out to the umbilical cord and then get back in. problems, but both come from a hiccup in this early process. Here's another one, a blueprint error in the diaphragm. So the diaphragm is supposed to be this wall separating your chest from your belly. But if the little part of it doesn't close up properly, organs from the abdomen can squeeze up into the chest. And the really dangerous part isn't the organs being in the wrong spot, it's that they crowd the lungs and don't give them room to grow. And sometimes, a mistake in a super tiny, almost forgotten part can have massive consequences. See, early on, we developed these little things in our neck called pharyngeal pouches. They're supposed to turn into really important glands, like the thymus, which is crucial for your immune system. Well, if they don't form right, like in DiGeorge syndrome, it can cause huge problems with immunity and how your body handles calcium, all from one tiny little glitch. So when you really step back and think about it, it's just breathtaking, isn't it? From just 3 simple sheets of cells, you get this incredible cascade of folding, the cells traveling all over the place, and turning into specialists, and all of that creates every single thing that makes you, you. In this book, it just nails it. Embryology isn't just a list of things happening, it's a cascade. Every single step depends entirely on the step before it being perfect. One tiny glitch in the code, at any point, can change the whole story. It's just so complex and honestly, so fragile. So that kind of leaves us with this final thought. When you see just how intricate and fragile this whole blueprint is, what does it really mean to be built, to be constructed from a single cell? It's really nothing short of a biological miracle happening all around us.